Here to tell us a little bit more about the findings of the trial for the electric side, I'd like to introduce to the stage Uwe Müller, who's the project manager for Volvo CE, and Andreas Sunesson, who's the project manager for Skanska. So over to you. Here's your buzzer.
Thanks.
So welcome to Results and Learnings in this project. My name is Andreas Sunesson. I work for Skanska in Sweden, working as a project leader for this project on Skanska side.
My name is Uwe Müller. I'm the responsible project manager from Volvo side, and we've been working closely together. And I think now we're going to give you a little bit an introduction, but we will start with explaining you what you really see here, because maybe not everybody knows. And then we go on a high level into the results, and then later on the day you get even more details. But I guess, Andreas, let's start this. What is Vikan about?
What is Vikan and what is the classic way of a quarry operation? I will start to give you a picture of what that looks like. And the best way, I think, is to show you the process from the beginning. We take blasted rock and we load that with an excavator into a mobile crusher. And from that mobile crusher, it goes out on the ground. And we use a wheel loader to pick it up again. The wheel loader, it loads it on dump trucks or stockpiling it into a buffer. We use these three dump trucks to haul it and then dump it into the tunnel station where it goes into the stationary crushing plant. So it's a quite typical quarry operation. All machines here, they run on diesel. And I can say one thing, there's one great thing about diesel, right, Uwe?
It is.
It's very, very flexible. And what you see here is a very flexible operation. On the upside of that, you can, there's a no low demand. No planning is to go too far, but there's a low demand for planning. And also a low demand for costly infrastructure investments. So that's something very good. But as you all know, there's a lot of downsides as well with this. The diesel consumption in this quarry is over 3,000 liters every day. And that gives, of course, a lot of CO2 emissions. And what you will see later on, we will talk about today, is when having a very flexible operation, you trade away efficiency. And most important, the safety and the working environment in this kind of operation. That is really a challenge. So Uwe, could we do something instead?
I think so, and that's what we see in the background, but I will step you through that, so to say. So if we take the classical setup as we have it, which Andreas just described, what have we done with that? First thing we have done is we take away those big rigid dump trucks that run on diesel, and we're going to replace them with a fleet of 8 fully battery electric and autonomous dump trucks, which we call the HX2. It's the same machines that you see one standing outside here. First step for the transport. The next thing we do then, we're going to replace a big wheel loader driven on diesel with a smaller wheel loader, which is a series hybrid, and that one we also only run in the morning shift. To load the HXs from one part. In the afternoon shift, where the classical wheel loader normally does stockpiling, we're going to replace it with an electric conveyor belt that builds the stockpile. And that's where in the next morning that wheel loader takes the material to load the HXs. And then the last step, the complete setup of crusher and excavator, we have electrified that by putting it on cable. So we have a cable electric excavator, which we call EX1. We have a cable electric crusher. And then we also, in that step, have implemented now the direct loading feature, because those autonomous trucks are designed in a way that they can line up behind each other, so we have a continuous flow of machines under the crusher that take the material directly from the crusher. So that's killing a complete work step, which is normally done by a wheel loader. So all that together, so to say, is clearly reducing diesel consumption. The only diesel we in reality have left is the series hybrid wheel loader. Then, with that, naturally, like Andreas also said, by reducing diesel, we immediately reduce CO2 emissions. Here, also worth mentioning is that the electricity that's supplied here from the grid side, and that's even an internal rule that Skanska has, so they only purchase carbon-neutral electricity. So from that perspective, we also feed green energy from the grid side into the system. And with that, we also see that we have a better work environment. What the people, for example, said, driving the wheel loader, if with an automated system, everything is much easier. It's more repetitive. They know exactly what's happening. It's less noise. So also for them, work environment is much improved. And for sure, talking about automation, less people involved, safety is for sure also increased. So, shall we look into results, I guess?
Yes.
We start with energy consumption, so to say. So in the classical setup today, like Andreas said, it's more than 3,000 liters of diesel that we burn here every day. And now what we've seen over the tests here in the 10 weeks, with the new setup, we just burn like 64 liters. You could mention, okay, how do you manage that? Pretty clear, through electricity, because today in the classical setup we have more or less zero electricity, but in the new one we have like 9,000 kilowatt hours over a day. And for the ones of you that have a hard time to compare what does that mean, electricity versus diesel, we calculated cost for this now here in Sweden in this use case, and that's reducing daily costs on energy from 33 kSEK down to around 10 kSEK. And that's a reduction on energy cost by 70%.
Very good.
So that's from going from diesel towards electricity. And as we mentioned about diesel and carbon emissions, Andreas, what does that mean from a carbon emission perspective?
Yeah, as we started with here, it's a win-win situation. So not only cost, but if you look at the next slide, we produce today here over 8 tons of CO2 every day. And as a consequence of going over to electric power, it is reduced to 166 kilograms every day. So that is a reduction of 98%. Quite remarkable. 98%. That's great.
Even above the target we had with 95.
Yeah, exactly. We had a target for 95%. So that's great. Great work.
But I think there's a bit more than that. We also talked about automation, so there's also some impact on how we involve people in the site. How does that look like, Andreas?
Exactly. When it comes to operator needs, as Uwe said, we have 2 different operations here in the morning and the afternoon shift. So in the morning shift, when we haul material, the need in the classic way, that is 5 operators. And in the electric site way, the need is 3 operators instead. So that's 2 in the machines and 1 system operator. In the afternoon shift, we stockpile material instead. So in the classic way, it's 2 operators. And the electric site way, since we used a belt conveyor for stockpiling instead, it's only 1 operator. So therefore, operative savings is 40%. So we see also that the operators can really add value in the pit by, more planning, preventive maintenance and stuff like that. Really good. Really good.
Okay, so to summarize that, we talked a lot about CO2 emissions, diesel consumption, but we also had a target on total cost for running a site like that. And there we mainly see 3 building blocks, which is the energy cost you have the operator cost, and then you have the machine savings or the machine cost as such. And there, as we mentioned earlier, we said we want to really be transparent here. The first blocks we know, that's really what we have learned now in this demonstration here. But what we don't really know right now is where the machine cost will finally land, because what we have running here today is prototypes. That's definitely not the cost we should show into this equation here, but that's also not what the purpose is. So the purpose here should be an industrialized solution which we can hand to our customers. So in reality, we had the target of 25%. We see we can save 70% on energy. We can save 40% on the operators. We know also, to be honest, that the machine is going to be a bit more expensive, for sure. It's more technology in it. There's some infrastructure investment. But with this, we, together with Skanska, clearly still believe that the 25% is possible. We are not there yet. It's still a way to go. But we both together firmly believe that this is possible. And that's clearly some of the hard facts learnings we've done here. But I think I've been here a lot, Andreas, you also have been here a lot. There's more than just figures that we also want to show you. So there's some more soft learnings which you also want to give you, and there's good ones. So there's opportunities, but there's also challenges. So let's take a look on that. And I think, yes. Andreas, you want to start with what we call potentials.
Yep. One of the results is the learnings. I think we agree on that. And if you look at the potential side, one thing we see is operator ease. And that's because we have this very precise planning and also automation. So the operation gets really predictable. So the guys know all the time where the vehicles will be, and everything is, as you think it will be. And that's something very positive. Another thing is less noise. It's noise of the rock, as you hear now. That is, we can't get away from that. But when going to electric motors, the noise is reduced a lot. Something very positive as well. The safety is increased, and that's not only because we remove the operators from the really dangerous zones, but also as a really interesting consequence of better planning. If you have better planning, you can do better risk hunting, and then you can take precautions, and that's something very good we see as well. We said a few things about partnership here in the beginning, and that's been very fruitful in this project. I think the mix of different perspectives, different competences really had made this possible. Also together with all these great people in the two companies. I think the partnerships, it's resting on the foundation of shared values between the two companies, Skanska and Volvo. And as working in the project, you can really feel that we have the same values and aim in the same direction, really. Very good.
Absolutely. But this sounds all too nice to be true. There's also some, I wouldn't call it downside, but we also had challenges, for sure. So just to give you some impression of that, one is for sure, like Andreas mentioned, it requires a lot of more planning, preparation, and we are not really used to that, and Skanska wasn't used to that. So that was really a learning we did together. But I think when we really set up everything here in the site, it was a great collaboration, so we got things to work. It was some struggle here and there, but we managed to do that, and we also see that this is more needed in the future, and that's something where we all need to learn together. On top of that, so to say, it's then the complete system complexity. Because like if you have an automation system like this, if one little thing goes down, if your Wi-Fi, you have one access point somewhere that goes down, then everything is standing. So it's really that everything needs to work to keep the complete system up and running. And that from that complexity to handle that complexity, that's also for sure a challenge and something we need to learn. On top of that then, talking about electric machines, batteries. Today it's a nice day, but it was quite cold this morning, and that's also something we need to learn. How do we treat those batteries? Not only in regards to temperatures, but also in regards to vibration, in regards to the complete environment we have here, and also how do we maintain the machines? How does Skanska use the machines? So that's also something not only we from a machine side need to learn how to treat batteries, it's also Skanska that has the machines and uses the machines, because the battery is kind of the heart of the electrified machines. And if they are dead, the machine is dead. So you need to treat them very well, and it's also a cost asset in the machine. And then there are some things where we say it's a potential on one side, but it's also a challenge on the other side. And there's again connectivity and site fleet management, which is again the system complexity, which has a lot of opportunities. We are much better in control. You know what's happening, you see what's happening, the operators see much more what's happening. But on the other side, again, you need to control it. It needs to work. And then on top of that, it's how do you service a system like that? We have our aftermarket personnel, Skanska has their mechanics here on the site, but this is something different. If you maintain an automation system like that, you probably need to have an IT technician as well on the site. And that's also something that we need to learn, and Skanska needs to learn to run their sites in the future. Yeah. And then, for sure, it's communication. Everything is connected, and communication is crucial. But it's also the communication between, like here we have the operators in the machines, like the wheeler operator, he's kind of communicating with the automation system. And that's also included in that, which is an opportunity and at the same time a challenge. But overall, this is helping us, I think, to work together.
Fantastic. Thank you both very much. Very good.